Hello student, today we'll discuss about the reverse Joule, Bryton, or also it is known as a Bell-Coleman cycle. This topic is covered in the unit refrigeration in thermal engineering 2 subject. At the end of this lecture, you will be able to understand the working of reverse Joule, Bryton or Bell-Coleman cycle. Also, you will be able to know the PV and TS diagram of the cycle and to know the COP of the cycle. Now, reverse Joule, Bryton and Bell-Coleman cycle working. As we already discussed in the earlier lecture, in the any refrigeration cycle, there are the main four components are there. The first one is known as a compressor, then there is a condenser, then there will be the expansion device, and last is the evaporator. These are the four components will be remain the same in any refrigeration cycle. So in the reverse Joule cycle, these four components will be there. But the expansion device is changed, which is known as a expander. There are the different expansion device has been used. Like in the reverse Carnot cycle, we use the turbine. In the Bell-Coleman cycle, we use the expander. Now, in the first is the compression process. In the compression process, the working medium is compressed. Here is important to note that the working medium is air. So in the Bell-Coleman cycle, the air is used as a working medium, or we can say air is a refrigerant. So first is the compressor. So in the compression process, the air is compressed. So its pressure and temperature is increased. When there is a compression process is going on, then there will be the reduction in the volume. So here pressure and temperature is increased, but volume is decreased. After that, this high pressure and high temperature air is goes to the another component which is known as a condenser. Here is condenser is a air cool condenser. So that high pressure and high temperature air is condensed here. So it is converted into the liquid form, but its pressure is high. So after that, the next component is the expander. So in the expander, the air is expanded. So its pressure and temperature both are decreased. So here in the expansion process, we will get the low pressure, low temperature air. Here is one of the important point to be noted that in the expander, we will have the work output. So this work output we will utilize to run the compressor by having the same shaft between the compressor and the expander. અહીંયા એક ઇમ્પોર્ટન્ટ વસ્તુ નોટ કરવાની છે કે જે એક્સપાન્ડર જે છે એમાંથી વર્ક મળે છે અને વર્કનું યુટિલાઇઝેશન આપણે કોમ્પ્રેશન ચલાવવા માટે કરીએ છીએ. જે કોમ્પ્રેસરનો શાફ્ટ અને એક્સપાન્ડરનો શાફ્ટ બંને કપલ રાખેલા હોય છે કે સેમ શાફ્ટ હોય છે, બરાબર. Then after the expansion process, the air which is at a low temperature and at a low pressure, it is goes to the evaporator. So here is the evaporator. Here we need to having the we need to produce the refrigerating effect, or we need to cool the space here. So this air which is at a low temperature and low pressure, it is goes to the evaporator. So the evaporator will produce the refrigerating effect by evaporating this low pressure and low temperature air. જ્યારે air એક ઠંડુ પ્રેશર હશે અને એકદમ લો ટેમ્પરેચર વાળી હશે એર, એ જ્યારે ઇવાપોરેટરમાં જાય ત્યારે જે સ્પેસની ગરમી હશે એને શોષશે, હીટ એબ્ઝોર્બ કરશે, જેથી જે લિક્વિડ એર છે ઇટ ઇઝ કન્વર્ટેડ ઇન્ટુ ધ વેપર. Then this vapor which is at a low pressure, it is goes to the compressor. So the whole working cycle will be the repeated. So first is the compressor, then it is goes to the condenser, then it is goes to the expander, then there will be the evaporator. This is the air refrigeration cycle which is utilizing for the aircraft in the older days. Now PV and TS diagram. So in the PV and TS diagram, first we will discuss about the PV. Similarly, we will discuss later on the TS diagram. In the PV diagram, as we already discussed, in the compression process, the pressure and temperature are increased. So from 1 to 2 is the pressure is increased from P1 to P2, and the temperature is also increased from T1 to T2. This process is a isentropic process. So what is isentropic process? The process which has a constant entropy process. So in that process, the theoretically there will be the no entropy change. There will be the no heat transfer to the surrounding. So this is the isentropic compressor. After that, it is goes to the condenser. In the condenser is the process is a constant pressure. Condenser માં constant pressure process છે. જે આ process જે 2 to 3 જે છે એ condensation process છે જે constant pressure એ થાય છે. બરાબર. પછી એ expansion માં થાય છે અથવા તો expansion process છે જે expander માં થાય છે. જેમાં isentropic expansion થાય છે. We already discussed in the expansion the pressure is reduced as well as the temperature is reduced. This is the temperature reduction. So the pressure is reduced and the temperature is reduced. Then it is goes to the evaporator. So in the evaporator, as we already discussed, the evaporator, the refrigerating effect is produced by evaporating the refrigerant. Here is the air is the refrigerant. So in this case, the evaporation process is the constant pressure process, and continuously heat is absorbed. So its pressure and temperature, its temperature is slightly increased by evaporating. That means heat is absorbed. So here the 4 to 1 is the process of evaporation. So in the Bell-Coleman cycle, where the PV diagram says that the 4 to 1 and 2 to 3 is the constant pressure process, or we precisely say that condenser and evaporator is the constant pressure process, and this compressor and expansion process is the isentropic process. Now TS diagram, as we already discussed with the PV diagram, in the TS diagram, this isentropic compression and isentropic expansion, it shows that there is a entropy is same, that is S3 is equal to S4 in the expansion process, as well as in the 1 to 2 compression process, S1 is equal to S2. So there is a no entropy change in the compression process and expansion process. Here is heat rejected and this one is a heat absorbed. So in the 4 to 1, heat is absorbed, so its temperature is increased from 4 to 1. And in the heat rejected, that means the temperature has been dropped from 2 to 3. So it's a condensation process, and this one is known as a evaporation process. So that is known as a TS diagram, that is a temperature and entropy diagram. Now objective is to find the COP, or to know the COP of the reverse Joule, Bryton or Bell-Coleman cycle. As in the exam, maybe the question may be asked as to explain the reverse Joule, or maybe directly they can ask that is explain the Bell-Coleman cycle. So we need to have the knowledge that reverse Joule, or the another name is a reverse Bryton, or somebody will say only the Bryton, and the popular name is the Bell-Coleman cycle. Exam માં ત્રણેય નામથી question આવી શકે છે. બરાબર. Also there is a example which is based on the Bell-Coleman cycle. So that's why we need to understand what is the COP of the Bell-Coleman cycle. exam માં Bell-Coleman cycle નો example પૂછાઈ શકે છે. એટલે એમાં COP નું calculation આપણને ખબર હોવી જોઈએ. So first is the heat absorb. As we already discussed in the working, heat absorbed is in the evaporator, is absorbed in the evaporator, as the process in the evaporator is 4 to 1. Similarly here 4 to 1, 4 to 1. So heat is absorbed. So This process is the constant pressure process. 4 to 1, that is the evaporation, and this 2 to 3 is the condensation. Both are the constant pressure process, and our target is to find the COP, and for the COP we need to have the heat absorbed and heat rejected. COP find કરવા માટે heat absorb અને heat rejected નો amount આપણને ખબર હોવી જોઈએ. તો કઈ બે પ્રોસેસમાં થાય છે? 4 to 1 માં થાય છે અને 2 to 3. તો 4 to 1 એ આપણું evaporation process છે. So heat absorbed in the evaporator, and because of the it's a constant pressure process, we need to have the Cp. Cp is the specific heat at a constant pressure, and m is the mass. So mass into Cp, there is a temperature mCp delta T. So temperature is changed from T1 to T4. So T1 minus T4, that is for the evaporation process. So heat absorbed in the evaporator we can write as a TDY principle, that is a mCp T1 minus T4. Similarly, we can write for the heat rejected in the condenser, that is equal to mCp T2 minus T3. Why T2 minus T3? The reason is heat rejected process is the 2 to 3, and T2 is the one of the highest temperature and T3 is the lower temperature for the 2 to 3 process. So we can write T2 minus T3 instead of T3 minus T2. So T2 is the higher value, so we need to have the T2 minus T3. In the case of the 2 to 3 process, that is the condensation process. So heat rejected in the condenser is equal to mCp. Why Cp? Again, because it's a constant process. So evaporator and condenser ma બંને constant pressure થાય છે, જેથી mCp, Cp is specific heat at a constant pressure, and there is a delta T, and there is a temperature change. So T2 minus T3. Now what is COP? COP we already discussed in the earlier lecture. The COP is a coefficient of performance, that is equal to refrigerating effect divided by W net. So refrigerating effect is where the refrigerating effect is produced in the evaporator. As we in the diagram, we already discussed that compressor, condenser, expander, there is a evaporator, and evaporator will produce the refrigerating effect. જે ચાર કોમ્પોનન્ટ માંથી આપણું જે ઇવાપોરેટર છે ત્યાં જ રેફ્રિજરેટિંગ ઇફેક્ટ પ્રોડ્યુસ થશે, ત્યાં જ ઠંડક મળશે. એટલે રેફ્રિજરેટિંગ ઇફેક્ટ જે છે એ ઇવાપોરેટર માંથી મળે, એ આપણો આઉટપુટ છે. અને આપણું આ કોમ્પ્રેશન વર્ક છે, જે આપણું ડબલ્યુ નેટ, જો એક્સપાન્ડર માંથી જે વર્ક મળ્યું ને ફાઇનલી જે વર્ક આપણે ડબલ્યુ નેટ મળે, સો દેટ ઇઝ અ ડબલ્યુ નેટ. સો in the COP, RE divided by W net. So RE is a evaporator process. So evaporator we have the mCp T1 minus T4. So we can write as a mCp T1 minus T4 instead of the RE. That is the process mCp T1 minus T4. Now I need to have the W net, but we have in the cycle heat absorb, amount of the heat absorb and amount of the heat rejected. W net હવે calculate કરવા માટે જો આપણી જોડે heat rejected હોય અને heat absorb હોય, so we can find the W net for any cycle. So W net જો heat absorb ને heat rejected હોય તો heat rejected minus heat absorb કરો તો W net મળી જાય. તો heat rejected, that is mCp T2 minus T3, mCp T2 minus T3, that is heat rejected, and heat absorb mCp T1 minus T4. Okay, so in this whole equation mCp is there, here is the mCp and here is the mCp. So mCp will be cancelled out, and we will have the final equation, that is the T1 minus T4 upon T2 minus T3 minus T1 minus T4. So in the COP, if you want to find the COP of Bell-Coleman cycle, or it is also known as a reverse Joule or Bryton cycle, we can have the whole temperature. ચાર temperature જો આપણી જોડે હોય, T1, T2, T3 અને T4. જો ચાર temperature આપણી જોડે હશે તો આપણે એનો COP Bell-Coleman cycle નો find કરી શકીએ by utilizing this equation. Also by utilizing the TDY principle, we can synchronize this equation by having the 3 temperature or by having the 2 temperature to find the COP of the particular Bell-Coleman cycle. So that is all about the reverse Joule, Bryton and Bell-Coleman cycle. In this lecture we discuss about the working of the Bell-Coleman cycle, its PV and TS diagram, and at the last, we derive the COP of the reverse Joule cycle, or it is also known as Bell-Coleman cycle. Thank you.